This is a recording of how to use the WBMsed model using the new RGIS framework that was recently installed on the University of Alabama High Performance Computer Cluster, or UAHPC for short. And this is using a new computer that was not used before, so it's also part of it is how to set up the computer, your Mac, to work with the model. Although here today I'm not going to install the RGIS framework on this computer. It can be done, but with the new RGIS framework on the HPC, we don't really need to do it, or the need for it is much less so than in the past. So let's just get started. So in order to interact with the UAHPC or the file that are stored there, I like to use a software called forklift. So I'll just Google it. And no, not Toyota. No. Here it is. Okay, so I Googled forklift Mac, and you can download and install this software for free as a trial. I mean, you can buy it, but if you download it and install it, you can, from my experience, basically use it in trial mode indefinitely, although I think it's the kind of diminished functionality. But for what we're trying to do, I think it's good enough. So let's just install it real quick. Actually, I don't think you even install it. It just... So we need to move it from the download to the apps folder, for the application folder. But for now, let's just use it from where it is. Continue free trial. It's fine. Dark mode I like to use. And start using forklift. Okay, so the reason why I like to use forklift, so it's kind of a fancy finders app, and so you can see there's a lot of functionality here. But what it makes life really easy is to connect to a server, to a remote server. So that's what we're going to use it. It's actually, for some reason, not very easy to do it from Finder. So we can use the connect here. And we use the SFTP protocol, which is what we have here. Add to favorite will be good because then we can give it name. Let's call it groups 1. This is the directory where most of the files that we need are going to be sitting. So the server is uahpc.ua.edu. The username, I'm going to use mine, but the Nook later you probably should change that for yours. By the way, so if you're doing this on UAHPC, you do need to create an account in advance, and you do it through the research computing website on the University of Alabama OIT. So I'm just going to use, and in the path here we're going to use groups1/scohen2. So groups 1 is as I said, it's a disk array on the UAHPC, and you can buy storage on that, which I did. So at the moment, the SDML, we have, I believe, 4 terabytes that we can use, but it definitely runs out quickly. So using groups 1, you should not keep your model results there indefinitely. And it's probably a good idea for you, even though you're using a different name, to still go to to navigate into the scohen2 path, because that's where all the input data and so on are. So I think that should work. Let's see. It did work. Okay, so now over here, this is the actual files or folders in this case that exist on the UAHPC on scohen2, on groups 1 scohen2. So you see how seamless it is, right? It's basically just like a native, almost like a native folders and files on your own computer. Let's do it again with a different folder, and I'm going to call it Big Home. Big Home is another, this is a free home, Big Home, because it's higher capacity. But yeah, we are trying actually to phase out of Big Home because OIT asked us to, not to store a lot of data there. So, but we still have something there that I want to look at, so I'm going to navigate to it as well. So the server is the same, uahpc.ua.edu, same username. Again, you will need to use your own, and the path is big home dot, so /s2. And I think on Big Home you can create your own folder, right? Tazmul, did you do that? Yeah, so you can create your own folder if you want to, but really, as I said, we're kind of phasing out of that, so I wouldn't worry about that. Okay, so this is Big Home here, and so this is Group 1, Big Home, and we can navigate between them. It's saved to the favorite. All right, so let's see if I can zoom in somehow. I guess we can try to make the text bigger. Okay, hopefully that will hold. All right, so we are at Groups 1, Cohen 2. So this is where most of the work is going to be done, and as you can see, there's a bunch of files here. So I'm going to go over them real quickly. The important one, anyway. Input data is a really important folder, and it's new. Those of you who've used WBMsed before, this is a new way to store the input data. So this is, as the name suggests, this is where all of our input data actually exists on. That we use to run the model. So it's a large folder. There's a lot of database here, and I want to go over what's inside input data real quickly. Can you see well? Or yeah. Can you read it? I mean, I think this is the largest font size that I can use. Yeah. Okay, so RGIS Archive 2. This is the new input data set for WBM Plus. So this is just downloaded a few weeks ago from the CCNY server, and it has, let me show you what it has. So actually this is, to be honest, just a subset of it that only looks at global. So the way the RGIS archive file or folder tree or folder structure works, you have a master folder for each domain. So in this case, we only have global, but if you have like a simulation, for example, for North America or for the Mississippi, so you can have subfolders, and I can show you how it looks, for example, in the old RGIS archive, right? So here we have global, we have the Ganges, we have India, and we have the Mekong. So let's just stick to this. So we have the global, this is all the global database here, and as you can see, there's a lot here. Now, we don't necessarily use all of them, but they are here, then potentially be useful. Let's look, for example, at air temperature, just as an example. Now, each parameter, input parameter, can have multiple databases that you can use. So in this case, there are 6 of them for air temperature. And each one of them is different. It's different extent. There may be different resolutions. So I don't see a different resolution here. They're all 30 minutes. This one has 60 and 150 minutes. But the file structure is very specific. So we had global, the domain, the parameter, air temperature, the database, right? And it has a specific name. And then the resolution, and as I said, there's multiple resolution, and within the resolution, you have the temporal resolution, if you will. So we have in this specific database of air temperature, we have annual files, and in this case, they go, let me extend this. They go between 1901 to 2002. That's just this specific database. I also want to draw your attention to this file extension. So GDBC, that's RGIS or GHAAS native format. So you can't really open it in anything outside of the what's called RGIS viewer. That's why we converted to NetCDF, so we can use it in different formats. But so this is the, as I said, RGIS native format, but then it has this .gz z, and that's a zip format. So what the RGIS, the new RGIS framework did, it allowed the model to read compressed input, so it saved a lot of memory on the hard drive. So that's a good thing. That's what the GZ here represent. But if we have some older input files, they will not have the .gz, but that's fine. That the model can still read them. So in this case, we have annual, we have monthly input, and there's also something called static in almost all of them. Sorry, not script, but static. And the static files are typically used for the spin-up period for the model. So it's important to understand. But this is the file structure, as I said, for the input, and it's very, very specific. Also, I want you to note the name of the file is also very specific. So domain, parameter, database, resolution, temporal resolution, so annual, LT stands for long term, and then the years. So for annual, it's going to look like this. Which year? ATS is annual time step, or time series, sorry. Anyway, we are not actually going to talk much today about how to generate new input files, only how to run the model, but still I think it's important to understand where the input data sits and what to do with it. So by the way, so very, very important, when you gain access to groups 1 to SCOIN 2, right, to my folder, you have a lot of power there, right? So make sure that you don't delete anything that you're not supposed to, because it's going to be difficult. It takes a few days to download and this archive too, and some of these files we don't have a lot of copies of them. So just make sure, leave input data alone. If you need to add something, that's fine, but don't ever delete it. And that's an easy mistake to make. So just be very careful. So we have some other stuff here, but what the next important thing is this, the WBMsed runs. That's the next important folder. And as you can see, let me kind of, there's a lot of folders here. These are basically different versions of the model that I've been using over the years. The new framework works with this one, the latest one, which is WBMsed 3.3. So let's go into it, and I'll explain to you how it works, and we're getting close to actually learning how to run the model. So we're going into this one specific model, and typically you would have scripts. We're going to look into it in a minute. Model, this is where the actual model code, the C code sits, and that's where you compile the model and do all that if you need to. And then GDS, we're going to talk a little bit more in a minute, but that's basically where the model simulation is going on. So that file is created once you start the model run. So that's actually different from the way the old RGIS framework used to do it a little bit, because it automatically puts it where the model and the scripts are. All right, let's talk about the model. Now, at this point in time, we are actually using model_new. So let's, for now, keep using it as our simulated model. It may change in the future, but for now, let's use it. Go and see what's inside here. So version description, this is actually not really up to date. Oh wow, that's really old. There should be what's going on here? There should be a newer version here, but anyway, I'm going to look for it. So we have WBM Plus. This is just a subfolder. And then we have SRC. This is where all the C scripts or the C module sits. And WBMsed or WBM Plus is a very modular modeling framework. So each one of these files represent a different module, a different part of the model simulation. So you see sediment flux. This is obviously the core of the WBMsed model. And then we have bedload flux. These are the two main files that we potentially are interested in. So if we want to make any changes to the sediment, suspended sediment or bedload component, this is where you do it. Again, changes in the code itself. And then there's also main. Sorry, where is main? Here it is. WBM main. This is less important, but this is as the name suggests, this is the main core. Let me just open it, and actually this is a good point to install another. Do you have a Text Wrangler?
No.
Okay, so a software that I use a lot on my Mac is Text Wrangler. Here it is. I think it's actually better to install it from iTunes than, although I think Danuk, it will ask you to log in. Do you have a?
Yeah, I can't remember. I think it's.
No.
Yeah, I can't remember.
Okay, let's install it from the website. And it's just that the website it used to be pretty good. Now they ask you to basically direct you to install. Maybe we can use it from here. So Text Wrangler, it's basically a very advanced text editing.
Can you take a selfie just by saying take a selfie? Take a selfie.
So I use it a lot. You can actually even run code from Text Wrangler if you need to, although I mainly use it as an advanced text editing application. It is. Okay, let's go back to, now the nice thing about forklift, that if you make a change, let's open it with Text Wrangler. If you make a change to the code, it will actually, when you save it, it will actually save it directly to the UAHPC. So that's a huge advantage over downloading it and changing it and then going back and forth and so on. So it does save it directly when you hit the save button. So this is just an example. This is the very messy suspended sediment module that I developed some years back, and as you can see, there's a lot of stuff here that at this point are not part of this tutorial, but just so you know, this is a C code. So I'm not going to save it. And the include has a bunch of these header files that are important to be here. The md.h, if you go to the developer manual that I have, you'll see that it's a very important file because it stores a lot of the parameter names that you need to set up, so it is an important one. And then bin, after you compile the model, the C script, it will create a .bin. That's basically the executable, if you will, if in Windows terms, the binary. So this is what it's called, WBM Plus. So again, we're not going to do any model development here, so I just want to know where it is and what it's for. Let's talk about the script. Now we get into where we are actually generating, we can actually start running the model. So there's a bunch of things here that you can see. It's a little messy right now because I actually use it to run scripts. Those error and output and this number is actually what's exported by the UAHPC queuing software, Slurm. So the name error is just give you the error that you have, and I actually see there's an error here, which is bad. So I'm trying to run the model now with a different input, and it's not really responding. And the output just gives you the output, what you would usually see on the screen if you run it in interactive mode. So we can actually delete those right now. Let's delete that. I'm gonna deal with these later. So the two important files in the scripts folder that we need to take care of are these two. The WBMsed monthly is the script that controls the model run. It tells the model, we're going to go over it in a minute, but in a nutshell, which input data set to use, which output to generate, what years to run, where is everything, and so on. It's a fairly complicated script, but it's absolutely the most important one for running the model. And the S batch is a script. It's a so-called Slurm script that basically tells the UAHPC that's how you submit a job to a supercomputer, basically, with this kind of script. And the supercomputer then, based on your input, decide which queue to put you in and how much resources to give you, and then what command to run. So let's start. We're going to talk about each one of those. Let's start with the model run script, as I like to call it. And as you can see, there's a bunch of versions here. By the way, these two, the bedload final and the bedload final 2, these are using the old model framework, and they should still work, I believe, but they're not exploiting the new model. But they're still. I'm keeping them here because there's some reason to have that legacy ability. But just so you know what they are, the WBM Daily. This is actually the one that Bolash, the developer of the framework, is using, and I have it here just as reference. WBM Monthly. You can change that name. The name itself is not important. Sorry, the WBMsed monthly. Sorry, the name itself is not important. It needs to be consistent with the S batch file, but you can give it a different name. You can create a copy for yourself, right? That's actually quite advisable. So if you run something very different, you could create a copy and then modify it so you have multiple files. So keep that in mind. You don't just have to keep modifying this one file. It's actually probably better not to, especially if we have multiple people running the model from the same location. Also, by the way, you can also copy this, the WBMsed 3.3, create a copy of it and run it so you know this is your own copy and no one mess around with it and so on. That's fine. You don't need to make a copy of the input data or anything like that. All right, so let's open the WBMsed monthly, and as you can see, open it in Text Wrangler. Let me try to increase the text size. Maybe view. Too big. Can you read it?
Yeah.
Okay. All right, so this is a lot of shell scripting. This is what it is. This is a shell script, has the .sh. It's a nasty language, but it's not very intuitive, but it is what it is. You just follow the general rules here. So a lot of, basically in the manual that I wrote, I updated it to this new script. So a lot of all this stuff is actually outlined and explained in the manual. But in a nutshell, I'm going to go over the important stuff here. I'm not going to cover everything. So this first line here, which is the model, it's set up. It tells it basically where is my bin, my executable. And you can see that you actually don't really need to change this unless you change the name of the folder where the model is. As you can see, model new, this is what we're using, or if you change the name of the bin, which is also possible. But for now, let's, unless you do any of that, you don't need to mess with this. The experiment, this is actually a very important and useful parameter. This is a name that you give to describe the experiment. So what are you running, right? Let's say I'm running, in this case you see with cyclone, so I'm trying to run some simulation that include and exclude tropical cyclones from the precipitation data set. So in this case, I'm trying to run it with the cyclone, so that's why this name. And this is going to appear, that name that you write here, is going to appear in the file, in the output file names, and in the output folder, subfolder basically. So this is an important name. So make sure that you modify or you change it to best describe the experiment that you're running. Because then, after if you run multiple experiments, it gets really messy without, so it's a very useful, as I said, function. Okay, this is another important, actually I'm going to need to do something in a minute, but the GHAAS DIR, or GHAAS is it's the name of all the tools and functions that runs the model framework, if that makes sense. So this is the background tools that, for example, take the input data and change its format to a specific data format that the model can use. So it's a very, very important, and this is actually, in a way, this was the main change of the new framework from the old framework. So it sits still, we may change this. At the moment it sits on Big Home, ESCO into RGIS, GHAAS. This is the new framework. Okay, the old one was in a different location, so keep that in mind. Now, this source GHAAS DIR, which is this guy over here, script function, these are the main functions that the model framework use, as I said, to manipulate and control the files and so on. So 23 is the new version. This is what really makes the new RGIS framework more efficient. So you see, when you have the hashtag, it means that it's comment out. So this is not active. I just leave it here for legacy. In a way, I can delete it. This line here, RGIS archive format netcdf, this is what is also new to the new RGIS framework. It basically tells the model to save the output files as netcdf. That's why we no longer need to convert the output to netcdf. This will do it for us, and will actually not save the output in the native GDBC format. It's now only saving it as netcdf, which is a huge advantage, because as Tazmol can testify, it can take a really long time to convert these. So this is a huge thing that we have. RGIS archive, this is where the main input data archive, so RGIS archive 2, as I showed you earlier, this is where the new archive is. However, for running WBMsed, so the sediment component, we need some additional archive, and I, in the past, decided to put them in different folders. Although they could all be stored in the same location, I decided to split them just for convenience. So we have what's called RGIS CSDMS. As you can see, it's quite old. It was when I was a postdoc at CSDMS. So, and it sits also in input data in RGIS archive CSDMS. We also have what's called mean inputs. That's another folder. Mean input is used, and although I'm trying to phase out of it, but it's still important. The way the suspended sediment is calculated, there's two parameters that are long-term average So you need to give long-term average input from the get-go, right? You can't wait for the model to run for 30 years. So I calculate those in advance, and these were used to be temperature and discharge, although now I've phased out of the discharge, and I'm using the model in embedded mean input, mean discharge parameter, but still temperature is in there, so you still need this. And again, this sits in input data, CSDMS mean input. Finally, not finally, but the next step is RGIS results. This is, you tell the script where do you want the output to be written. So in this case, I decided to put it in groups 1, Sagy-Cohen 2, and WBMsed output. This is, you can easily change it, right? So feel free to change this. So you can give it a different name. You don't need to create the folder ahead of time. The model will do it for you. But if I wanted, for example, call it WBMsed output 2, because I don't know, I want to split it. There's not much incentive to do that, to be honest, but you can do it. There's no harm. Start year and end year, as the name suggests. Start year and end year, right? And it's these are obviously very important. It tells you what is the first year and last year of simulations. You need to make sure that you have the appropriate input data for that, mainly the climate, so precipitation and temperature. With the new RGIS archive, we could go back to 1901 and go all the way to 2016. But if you don't need to run, obviously, the more you have, the longer it's going to the longer it's going to take to simulate. But also, it's going to generate a huge database. So if you don't need that long, so in this case, I'm trying to match an old experiment, so I'm only doing 1980 to 2010. And end year here, this is actually can be removed. All right, now these guys, these 5 lines define the climate input data, and the specific syntax is very rigid, so you shouldn't change that. The only thing you can control, you potentially need to control is this. This is the name of the input. So if I go back here, just to remind you, right, input data, RGIS archive 2, global, and let's say precipitation. We have all of these, right, I don't know, 15 different precipitation input data. So this is where you control which one. So we are using CRU TS. This is the one that has the data from 1901 to 2016, so it's a good input data to use. Now, one thing to understand about the standard precipitation data that we use in WBM, the way we've been doing it in recent years, although you don't have to do it this way necessarily, you have monthly precipitation data, but it's fractioned into daily precipitation using a different data set. And the exact mechanism of how and why it's done, I can't really tell you, but this is sort of how we do. It's called daily precipitation fraction. But unless you need to change the input climate data, you don't need to worry about that. Now, another important parameter that you need to potentially be aware of is this, net version. This controls which network the model is going to use for this simulation. Now, the network is actually extremely important for WBM because this is where basically it tells it where is the river, where are the rivers, right? What is the flow direction, flow accumulation, and all of these stream network characteristics. So different network files are slightly different from one another. And this is a new one, Hydro STN30. So this is the one that we're currently using. And the consequence of changing it is the fact that some of the model, not especially, but I think exclusively the suspended sediment component are network specific, meaning if you use a different network, you need to change or you need to recalculate some of the inputs, especially the relief parameter, as well as the dams, as the Nuke now is working on that. And so this is the new network that we're currently using. This may change in the future, but that's so you don't necessarily want to mess with it. And also you see here what they decided to do is to to use different network for different resolutions. So for 30-minute resolution, arc minute meaning special resolution, we use this. Sorry, we use this, and for the final resolution, we use this. Okay, so yeah,
Question.
yeah.
Are these network files already calculated?
Yes.
Or is it calculated on the fly?
No, they are calculated already. They are ready. There's a conversion going on, so that when you run the model, the simulation, the first thing it does, if it's not already done before, is to create a separate file in the GDS folder. I'm going to show that to you in a minute. But yeah, you don't need to mess with it at all. Okay, this is another very important section of the script. FW arguments, and there's a bunch of options here that you that you will probably need to change. So S stands for Spinoff, and you can see by it's on right now. So Spinoff is when you start the simulation, it will spin off. It will run the model for this number of times. In this case, it's 2, although you should try to use 10. I'm using here. I define it as 2 because I'm doing some testing for the model. But usually we use 10 spin-off. So what it means, it will run the model for 10 times with the static data. It will fill in all the buckets of groundwater, soil moisture, stream water, and so on. And after 10 cycles, 10 years of basically spin-off, it will start actually simulating the yearly or the daily data. So start with, in this case, 1980. So when you start the model simulation, you will see that it takes a while until it actually starts producing output, because it does these 10 spin-off cycles. So this is where you define it. When you can set it to off, if you already ran a spin-off cycle and you ran a simulation, but you change in maybe one thing, and or you need to run it again for some reason, if you didn't delete the GDS folder, you can set spin-off to off, and then what WBM is going to do is going to take the last simulation result as the end of the spin-off, if that makes sense. So it saves you the spin-off cycle, but because the model is pretty quick now, it's not a big deal. 10 spin-off cycle will probably take you 4 hours to simulate, so it's not a huge deal, but sometimes you can get rid of it. So minus S, again, this is to set spin-off on and off. Minus N is the number of spin-off cycles. F, I actually don't remember what that. D, capital D, is daily. That's where you set if you want the model to output daily files. This is a very important option, because if you don't, the model is still going to run at daily time steps, but the problem with daily output is that they are very large. So if you are simulating for many years and outputting many parameters, if you output in daily files, it can get big very quickly. So if you don't feel like you would need to analyze daily model output, definitely set it to off. As you can see right now, I'm trying to do daily, but P, minus P, there's no real reason to set it to off. That's basically the parallel and the model efficiency parameter, so just leave it as on for now.
So if you switch daily to off and then run the model, what type of output would you get?
It will only generate annual and monthly,
I see.
which, as I said, will save you a ton of disk space. All right, the next part, it's the long list of data sources. This is the input files for the model, or files and parameters. Now, as you can see, again, this is have a very picky or very specific syntax. And most of the input have static and dynamic input files, and the static is used for the Spinoff, and the dynamic, unless it's always static, is used for when you have time varying input like precipitation. Let me increase this. So I don't want to go really into how to really set up a new one, but the important thing to know here is these arguments here. So this is the name of the input data set that you're going to use. So this is precipitation, and I already showed you, right, that we have different precipitation databases. So this is how you change them. I showed you up here. These are only for precipitation and temperature. So they decided to put them up here because they are arguably the most frequently changed. But this is where all the other stuff is. So if you want to change, for example, the name of the reservoir. So we are working on a new reservoir capacity model. This is the old one. Once we change it and we can use it, the new one, we will change the name here. All right, and so this is where, as I said, you tell the model which input files to use. This is very picky, and a lot of times the model will crash because you didn't do it right, or it can't find the specific database that you told it. So this is one of the first places you look for when the model didn't run successfully. And again, there's more explanation about this in the manual. The next set of lines here are the options. And as you can see, there's quite a few. The most important one for us is the model. The model, there are a number of options. As you can see now, it's set up for sediment flux. There's also balance, discharge. There is bed load flux, there's water density, basically any kind of, now what this controls is which module is going to control the whole simulation. Basically that's what it's saying. If you said discharge, for example, or balance, which is water balance, and you're trying to simulate sediment, you're going to set up the sediment output as active. It's not going to simulate sediment because it's not linked directly to sediment. Sediment is not a dependency of discharge. So for us, for this group, if we just want to do pure hydrology, balance is the best approach to go. If you're not interested in sediment at all, balance is what Bolash uses, for example. This is the kind of the default hydrology module. And discharge is I think a Skinner version of that. Bed load flux, as the name suggests, to have the bed load. Although now we can actually calculate bed load using sediment flux as well. I'm going to show you how. Water density is just a different module that I created for calculating water density. Now, as you can see, there's a bunch of other parameters here. We generally don't really touch those. The only one that I messed with a little bit, there's actually two that are important. One is precipitation. As you can see, there's one here that I commented out. This is actually the default. Precipitation fraction is doing what I just described earlier. It's taking the monthly precipitation files and fraction them to daily model. I commented it out in this specific script because I'm trying to use input, so direct, I'm trying to use direct daily input for this specific simulation, so far unsuccessfully, but for this module. Anyway, for you, basically, unless you're using your own input precipitation data, you will need to use the fraction options. Need to do something like this, uncomment this and comment this. I'm gonna undo this because you know what, I'll do this. There's also, I've messed around in the past with the potential evapotranspiration module. Hammond is the simple default one. The Turk is one that I'm probably going to go back to using because I found it to do a much better job in the Arctic. So Arctic rivers are very much influenced by spring melting. So the Turk model do a better job at capturing the snow melting in the Arctic.
Now, above these options, we have in the folders, it's the input data sets. So the code above this part, it links to the input data.
Mm-hmm.
And what does this part do? Because here is also we see precipitation. So
This is option. Think about it as switches or dials that you switch between different modes. You say, I want you to use this specific evapotranspiration module, and the model have many different. So this is how you tell something that's not. It's not necessarily about which input to use, but what kind of equation to use, if that makes sense. So it's kind of a deeper. And there's different ones. There's some parameters here. So it's different options that you can change. Most of them I've never really touched or never messed with. Okay, the next part of the section of code, and as you can see, most of it is commented out, is the outputs. This is where you tell the model which outputs to generate. Because if you want to, you can generate dozens of outputs. But first of all, they're not necessary. And second of all, if you do that, you're going to really slow down your simulation time and you're going to take a lot of disk space. So you want to be, on one hand, very selective, basically output as few parameters as possible, but also don't be too stingy, because if you run the simulation, you might as well generate something that you think you may use, if that makes sense, right? So as my output, that's pretty much always the case. I always want to generate discharge, even if I'm doing just sediment, because discharge is basically controlling everything. Runoff is not very commonly used. I'm just using it now for some of the model testing. Sediment flux is, well, the suspended sediment. There's all these are all parameters of the WBMsed equations. So sometimes it's good to output them if you're trying to understand what's going on. Kind of open the black box, if you will, to see, okay, what is the, for example, the T parameter, what does it calculate it? So if the model works fine, and you don't need to debug it, or if you don't need to really investigate what's going on, you don't need to output these. Some other important QS bar, it's a fairly static output. It's the long-term average suspended sediment. I like to output it because I found it to actually be more accurate than suspended sediment for more accurate than sediment flux for long-term average predictions. So I like to output it. Bed load flux is here, and that's the main thing. You see, there's all these nutrients here if you need them, water temperature, water density, and so on. Most of these you're probably not going to be needing to export. But if you do want to, let's say, for example, we want to export bed load, all I do is uncomment. So delete the hashtag here. And if I want to, let's say I don't want to export runoff, I just put hashtag here. And don't forget to save, right, when you're ready to run it. It's very easy to forget. If you don't save it, which is Command S, it's like you did nothing, basically. It's not going to make any difference. Some other options here, don't worry about those. And that's pretty much it. Here, basically what these 4 lines is basically tells the model, go investigate the input data sources, go investigate, get ready the output, and eventually run the model. You don't need to change any of this, so you don't need to touch any of these here. All right, so this was the model simulation script that controls how the simulation is going to go. Do you have any questions about it? No, it's quite heavy duty. There's a lot here.
So I have a question. Now, let's say we only want to simulate sediment flux, and we have 5 different equations to simulate sediment flux. So do we have to first go look at the equation and then determine, okay, what type of inputs do we need, and then switch on the options?
Well, you need to have them first of all coded in your C code. You can't just.
Let's say that we already have them.
Okay.
Yeah. 5 different options to
Yeah.
simulate sediment. So do we have, then we go into the options and then select the appropriate one, right?
Well, I mean, we don't have a parameter right now that can do it. Actually, there is one parameter here that I should have said, should have actually told you so, is this one. This is called sed pristine. And what this is doing is setting up, controlling between three different type of sediment calculation. One, which is disturbed, meaning it's going to have dams, it's going to have what's called the EH, anthropogenic input, and that's 0 value. So that's sort of the default that we have right now. If you want to simulate pristine suspended sediment, meaning that you don't have anthropogenic input, you need to change that value to either 1, which is fully pristine, or 2, which is what I call semi-pristine, which means that blah blah blah. I forgot which one is it. Either the dams. I think no. In this case, EH. No dams. T is the trapping efficiency parameter. So it basically says there are no dams. So I don't take any dams. Now this is different than running the hydrology in pristine versus disturbed mode. So we're gonna talk about that in a minute. But that's an example of how you do it, right? So the way this works, there's a parameter in the C code for sediment flux, and it looks at what value you give it, and there's just an if statement there that says if sediment pristine equals 0, then do this. If sediment pristine equals 1, do this. So this is my primitive way to do that. I'm sure Baloch has better ways to actually do this. But this is one way to do that. So you can think about, you have multiple sediment equation, you can just say control this by doing that. Okay, any other? So I saved it, I think. So Command S, and that should have saved it here, although I didn't see. Usually it gives a message when it does that. Let's investigate. I'm going to go to model run. Here it is. WBMsed run. Said, yeah, we changed it today at 5:05, so we're good. Yeah, that should be okay. Now, if I'm not sure, I can just double click and open it, or I can. By the way, in the Mac, I don't know if you're familiar with that. The spacebar key, open a preview. So all I did is I selected a file, right, and I hit the spacebar, and it will open this preview if it can read it. In this case, it can. So this is a quick way to kind of investigate. Also on the left here in forklift, you have this preview over here if you want to look. So I don't know if you can change it. I think you can change it, or maybe not. Here it is, save. That's comfortable. So you can change it from here. You don't even need to open it in Text Wrangler, although Text Wrangler is kind of color coded, so it's a little bit nicer. But okay, that's good. Another thing that I want to teach you, you know what, let's do it later. All right, so we set up the model simulation. Let me actually do something really quickly here. I want to restore it because I want it to be a successful simulation. I want to restore it to its original form, so it's actually running, because I kind of changed things around earlier and it's not running. So I'm gonna do this, and I'm going to, use fraction, that's fine, Control S, not Control, sorry, Command S, saved it, right, 510, good. All right, so the next thing, before we run the model, we need to modify the S-batch file. Let's open it. So let's change the, where was it? Font. Where was it?
Was it under view?
Just do this. Okay, so this is also very specific. This is, as I said, this is a script, another shell script that's used by the UAHPC Slurm queuing framework. I guess that's how you would call it. So if you go to the research computing website, they have some examples of this code. I'm going to go over it real quickly. You do need to follow the specific syntax. So job name. And this is also in the manual, I added that. That's just the name that's going to be printed or going to be stored in the queuing system. It's not very important. It's only important if you have multiple jobs and you want to look at them and see how they're doing. It's not going to impact your output or file name or anything like that. So it's as I said, it's mainly important if you have multiple runs that you want to do. N minus N and some number, that's how many cores are you asking to use. Now we, in the owner's queue that we have, so SDML, we have 16 cores available to us. So we need to share them if we want to use the owner's queue, which is a huge advantage, as Tasmuk discovered, because if you go to the general queue, you may need to wait in line quite a bit. Yeah, we only have 8, so I run the model with 8. If no one else is running it, 16 should improve its performances quite a bit. But I do it because, so for example, Miriam is running a different simulation using 8, so we only have 8 available right now. Mem is for how much memory you're asking. This is RAM memory. If you ask too much, there's only a few nodes in UAHPC that has over 32 gigs. So my experience, if you ask for 64, for example, you may still wait in line because even though you're using the owner's queue, there's only a few nodes that allow you to run 64 gig jobs. So 32 should be more than enough for running WBMsed. So I think that should be good enough. Now these 2 lines here is how you tell Slurm which queue you want to go for. So minus P is the owners, right? This is what we have. But if this is not available to you, you can go with long. This is to run long simulation, I think for, do you remember how long they could be? I think a week, maybe?
Yeah, 1 week.
I think about a week.
For main is for 24 hours?
Yeah, main is 24 hours, which is not enough most cases. But it's the biggest queue, so this is, if you run short simulation, that's one way to go. Owners have no limit on the number, on the length, but you also need to define this. So QoS, whatever that is, and my username. So you can't use your username, I don't think.
So I tried like yours and mine when I was running the long queue, but that's...
No, for the long queue, it doesn't matter. Because I have no privileges in the long.
I also like comment out like without that, but it was showing me like QS not allowed.
Well, I guess we can look very quickly into research.
Because in their manual I saw like I have to specify like project investigator group name or something like that.
It's been a long time since I used anything other than owners, but if you go to the support and getting started, maybe not, here it is. Q's main. Okay, so this is how you change it. So not underscore P, minus P, so it's minus Q's main or long or something like that. But without my username because, yeah, I mean, that doesn't help. It doesn't change anything. So, yeah, if you need to go to one of the public queues, then you need to change it here. This is the name of those error and output files that I showed you just a minute ago. You can change the name if you want to call them something else. This %J is just going to give the job number to it. So okay, now this is important. This is basically the command to run. So all of this is basically asking Slurm for some specific properties of I need this much memory, I need this many queue, this is the queue that I need, and so on. After you finish with those, this is the actual command that you're going to run. So under /, this is just a Linux command for running a script. The name of the script, has to be the same name as the script that you just edited, right? If you change the name, it's going to look at something else. If that name doesn't exist, then it's going to fail. So this is important, right? If you use a different file name, a different script name, this is where you change it. Global is the domain, right? If you have a different domain, this is how you would tell it. Dist is disturb. Dist is one option. Disturb, as we said, meaning that there's full anthropogenic effect on the hydrology. So that include dams, dam operations, irrigation, groundwater uptake, all the stuff that humans affect the hydrological cycle. And then the last argument here is the resolution that you want to run it with. Now we run 6 minute 06 min resolution. So this is 6 arc minute. So it's about 11 kilometer by 11 kilometer grid cells. And that's very important. Now with the new framework, we can start thinking about running it at higher resolution. But because the sediment component is network specific, it may not work very well. So for now, unless you really have to, let's keep it with 6 arc minute resolution. So if you change anything here, we didn't change anything, but if you did, don't forget to save, right? Otherwise that didn't happen. So now we're getting ready to really run the model. So we have these two guys, this and this, these are the two important. And they're, as you can see, they're in the same folder. That's useful. What we're going to do now, we're going to use the terminal to navigate into this location and to basically, actually there's some pre-step that I want to show you real quickly there. That could be very important, actually pretty crucial. So I'm going to go and use the terminal. By the way, I'm using a different terminal software that's called Terminal 1, is it called, right? iTerm. And you can download it for free. It's actually the new terminal in Mac is actually pretty good, so there's not much need for that anymore. But the iTerm allow you to to modify it a little bit. Okay, so I'm trying to think, Danuk, if I should log in with you or I should just... I'm going to log in with my own name, but the reason why... We're going to do two things in a minute. Okay, let me first log in with my name. So if this name over here if it's the same... let's see if we can... let's see if we can, yeah, okay. If this is the same username as your UAHPC, you can just use SSH UAHPC hpc.ua.edu. Now, so this is if, again, this is the same username that you have. If it's not, which is obviously the case for me, I need to do this. SSH scohen2, this is my username, at UAHPC. It's going to prompt you for the password. And now you're in what's called the head node. The head node is the kind of welcoming node, if you will, or the main node that controls what you do. Now I want you to know these two things over here. These are going to be important, and I'm going to talk about them in a minute. These are two modules that I load every time I log into UAHPC, and they are actually pretty important for either compiling the model or running the model, and I'm going to show you in a minute how to add them. So one way to do it, actually, if you need to do it manually, you use this. This is a command. Let's say UD units 226. It says it's already loaded, but that's fine, right? And or you can also do use, I think all. Yeah. So use all basically give you a list of all the modules that are now available on UAHPC. You see MATLAB here, for example. I don't know, all these C compilers. CMake is an important one for us, but we don't need to worry about it. All these different Python versions and so on. So if you need to use one of them, WRF, NoIMP, WRF Hydro, those of you who know a little bit about that. This is how you would potentially load them. And if there's a package that you need, you just need to ask OIT to install it. So I want to show you, so you can do this manually, right? You log in, you do use UD units 22, whatever that was, 22 UD units 226, or you can add this use command into your profile file. So let me tell you what this is. I'm gonna CD to my main entry folder, which I'm already at actually. And if I do ls all, it's gonna give me all the hidden files that I can't really see. One of them, you see there's .bash profile, and sometimes you also have point profile, which I don't see.
About the green
Here it is. Okay. This is a little confusing because you're sometimes not sure which one to use. I think for UAHPC by default we use the bash underscore profile. So let me look into it. The way to do it within the terminal is use a little package called VI. VI is basically a text editor for the terminal, and I'm going to do .bash, and I'm going to use the tab key to autocomplete. You see it's not sure because there's multiple bash. All right, so there's a couple of things that you would want to add to your, or you may need to change later on. I want you to note this one over here. Export GHIAS dir, and this basically tells that every time you log into UAHPC, it tells it that there's this parameter GHIAS dir, and this is the folder that it's at. That, to be honest, for you guys, it may not be crucial, but when you do a lot of the model development, that may be a little bit more. But there's no harm anyway to do that, and I'm going to show you how you can edit in a minute. And the other things that I want to show you is this. The use UD unit 226 and use GCC 4.48. And I also want you to know that they are at the end of your script. So what I'm going to do now, I'm going to set this up for Danook actually. So I'm going to use the Command T. I'm going to open a new tab. And so Danook, come here because you need to create. Is this the same username?
Yes, I think
Okay, so SSH UA.edu. UAHPC. So,
Yeah.
no, it should be the same as my Dharma account.
What,
Yeah.
do you have an account?
Yeah, I do have an account.
I know password.
Yeah, my Dharma. Okay, so we're already, so let's do the same. Let's do ls all just to see what you have. Okay, you have the bash profile, so we're going to do vi dot bash profile. All right, so I need to add a bunch of lines here. So the VI software has a specific way to interact with it. It's not like your typical, text editor. So what I'm going to do, I'm going to copy this, just because it make my life easier. And I'm going to go back here. So I'm using the arrow keys. You see, I can kind of move the cursor. Now, if I want to type something, if I just if I start clicking some keys, it's not going to do anything. I need to initiate or go into editing mode or writing mode. And to do that, I hit the I key on my keyboard. Now I can write. And I think I can just Command V, to paste it. So that was easy enough. And now I'm going to also copy paste these to this. You know what? Let's do these three. I'm going to copy them. And I think these are for sure, and these are in the manual. I'm not sure I have this, but it's not actually very important for us. So I'm already in editing mode, so I'm just going to navigate with the mouse, with the arrows to the bottom of the script, and going to do Command V. And now that I'm done with typing, I'm hitting the Escape key. That will get me out of editing mode. And what I want to do now is run what's called the Save and Quit command. So I'm Shift semicolon, and then WQ. See that at the bottom here? So what this did, W for save, Q for quit. So if I go back and do, by the way, if you want to navigate between different commands on Linux, you can use the up and down keys. So if I go back, I see that it's saved. Now I can do Q to exit. But it only takes effect the next time I enter or log in. So I went to exit, and now I'm back into my computer and I can SSH again. But let's just use my user for now. All right, so we need to navigate into our script folder in order to run the model. So cd groups 1, SQL2, WBMsed runs, and WBMsed 3.3 and script. By the way, you see how I type it very quickly. You hit the tab key and it will auto-complete depending on what you have in that folder. I also want you to note the slash. So I started with a slash, right? Because this is I'm going directly to this location. So now I'm in scripts, and if I'm not sure, I can run the pwd command. What it does, it tells you your current location, so I'm in the right place. And I can use the ls to look at the available files. So what we're going to do, we're going to run, or we're going to submit, actually before I'm going to submit, I think I have a simulation going on right now that's I should terminate because it's not going very well. So I can check the current jobs on UAHPC using the SQ command. And as you can see, there's quite a few here. So you can start looking for yours, but that's, as you can see, quite difficult. So a way to do it is to use the U option and then your user. That will only display your own run. So we need this number over here, the job ID, because I'm going to cancel this job because it's not going very well. So in order to do that, I run the command s cancel, and then 37, that's the name, 370204. And now I run this again, and you see there's nothing here, so I'm good. So I canceled this run, I terminated it. Make sure you do that because if your model is not running well, sometimes it will not crash. It will just keep on going, and therefore just basically taking over the resources that we have. So make sure you cancel stuff that's not working. All right, so now we're ready to run our script. So we're going to use the S batch command, smaller than the name of the S batch script. This is a pretty unique syntax, right? So sbash is the command that tells I want you to submit a job to Slurm, and this is just the way it's done, smaller than and the name of the script that we just generated. So make sure you're not confusing this script, the sbash owner, with the WBM monthly. That's not gonna run. Actually, you know what? Before I submit it, I'm gonna show you something real quickly. So I'm gonna just delete that for a minute. I can, if I choose to, I shouldn't do it on a regular basis, but if I choose to, especially for quick debugging, I can run the model, the WBM monthly script, directly from here, from the head node. Now, it's a big no-no to do because if you do it, the model starts simulating, but it's now using the head node as the simulation node, and therefore it will clog the head node for all the other users in the system. So you're not going to make the system administrator very happy, but I'm just going to do it very quickly to show you how it looks. So /WBMsed monthly global dist, it's just like that line that we saw earlier, 0.6 minutes. So it start giving me some feedback, and it's going to start. It's basically running. Now the model is running, so I don't want to keep it running because, as we said, it's not a good thing. So I use the Control-C to cancel any command. All right, so we saw that this is sometimes useful because a lot of time, especially if now we have a new framework, the model, you start the model and it crashes almost immediately, so then you need to go to the output and see what the output text is and so on. So sometimes even just running this way, you know it's going to crash, but you just want to see the output very quickly. Sometimes I find it useful. Actually, I've been using the wrong. So sbatch. All right, so now it tells me I submitted a batch job and this is the number of the job. So now I'm going to use the SQ to look at my job. So there's a bunch of somewhat useful information here. We have the job ID that we saw is important if we want to cancel the job. There's the petition, the owner's queue, the name that we set up, which is, as we said, not very important, the username, and this is the important part. This is for the status. R means that it's running, so that's good. P meaning that it's pending, and I guess sometimes if it's not crashing immediately, maybe, I don't know, there's maybe some other, but the two main important ones is R and P. If it's in P, and sometimes it gives you a reason why it's in P, in pending, why it is. Sometimes it says you ask for too many resources, or the quota is, we're out of quota, and so on. So that could be an important output. And then time is the simulation time, so how long it's been running. So if I'm going to run this command again, now it's running for 1 minute and 10 seconds, tells me which node it's using. For us, it's not very important because we only use 8 cores. So each node have many cores, I don't know how many, but sometimes it will use more than one node because it needs to, it doesn't have enough cores in each one, but anyway. So, okay, so now the model is running. Let's see what it's actually doing. So if we go back here to our WBMsed 3.3 folder, we have this GDS folder. This is where the intermediate files are generated and calculated. So let's go here. Okay, so you see this global network 06. This is the network file that I told you about. So if you start from scratch, meaning you have no GDS folder, the first thing the model is going to do is going to generate the network file. So, or if you're using a different network, you probably need to delete this file. But this is the network file, but it only needs to be calculated once unless you delete GDS, which you actually can't because for some reason it doesn't let me delete these two folders. So I guess we're going to be stuck with it for a while. But as you can see, there's all these subfolders here. And these are the current, the last couple of simulations that I did. So here's the one that I tried to run from the head node. I can delete it. Let's delete it. Aha. It doesn't like that. That's quite annoying. I'm not sure why, but sometimes it's just not very responsive. Now, actually, we are, yeah, this is it. This is the one that we just started. Okay, so let's navigate into this one. All right, so what the model is doing, you see there's different files here, and each one, this is actually kind of a little concerning, to be honest, because it shouldn't go all the way. Well, maybe, no, I think it's working. No, it's okay, it's okay. So there's some old files here, you see, from, well, I don't know, they're not that old. Anyway, but it will start generating those files, and because we have a spin-up cycle, that it may not look like it's doing much at first, but once it starts simulating the specific years, you'll see it start giving the year number here, so 1981 and so on. And it also provides very useful log files that can be quite informative, especially if the model is not working properly. We don't, yeah, there's no need for, at this point, to go into that, but these files are very useful to debugging or to figure out if something went wrong. But basically, this is where the model will start working. And one annoying thing about forklift is the way that when it's connected to a server, it's not actually updating the view. So this, even though these files may change, or maybe new files have been generated, it's not going to change. It's not going to show us that there's actually no refresh option, to the best of my knowledge. So the trick that I've started using is either generating a new file. If you kind of go and do, it's actually going to be difficult here. We have so many files. But maybe let's delete one of these old files. So if I delete this file, or generate a new file, it will actually refresh the view. So this is the trick if you need to refresh the view in forklift. So you may need to do it quite often if you want to see what's going on. So this is simulating, however long, and usually with head cores, it takes about half an hour for 1 hour of for 1 year of simulation. So, you can expect it to be quite a number of hours, especially if you have 10 spin-up cycles. But once it starts generating output, we said that we want the output to be written into this WBMsed output. So we have some old files here. So let's see, there's some old simulation here. And there's just a very specific way that the new framework, those of you who've used the old one, the output was arranged in a very different way. Here, even if you run multiple simulation, it's still going to keep that same structure, but then just add subfolders for each new simulation that you've done. And also it kind of already split it into monthly, annual, and daily output files. But generally, as you can also see, it's also generated the .nc, so that's netcdf. So we don't need to convert. And then once the simulation is done and you want to download it to your own computer, what you can do is, for example, you navigate to desktop, although that's not a good place to put things, and you can just drag either specific parameter, or you can just drag this whole thing and just copy it here. And that obviously can take a long time, especially for a large database. But if you do that, you'll see that, let's actually do that. Let's do this. We'll delete it later, but well, that you see, it tells you how much it downloaded and what's the download speed. I'm actually kind of curious to see how fast it goes on your computer. 25 megabytes per second, that's a little slow. I hope that, by the way, you can turn off the Wi-Fi. That's not very helpful, but I don't think that's a problem. Anyway, it may take a while. Okay, it may take a while to download it. The alternative is to use a command called scp, especially if you do it from your computer. So I'm now looking at the Linux computer, and I can do scpr, which tells it to look for a specific folder, and then scoin2 at uahpc.ua.edu, groups 1, scoin2, and then you get the drift, right? WBMsed output, and then space and the name, the location on this local computer. So let's say, I don't know, desktop. I don't know. So if I do this, I think it's going to work.